NASA just fixed a computer from 1977, not in a museum and not in a lab, but in deep space, farther away than any human-made object has ever been. Voyager 1 is so distant that a message from Earth takes about 22.5 hours to reach it, and another 22.5 hours for the reply to come back. Every attempt to diagnose a problem takes almost 2 full days, and that is what made this rescue so extraordinary. In late 2023, something went wrong aboard Voyager 1. The spacecraft was still alive, still receiving commands, and still transmitting a signal back to Earth, but the data inside that signal had turned into nonsense. That was the real problem. If Voyager had gone silent, the story would have been simpler. Silence usually means something has died, but Voyager was still talking. It just was not making sense anymore, and that is much harder to fix. Voyager 1 launched in 1977. It flew past Jupiter and Saturn, became the first human-made object to enter interstellar space, and then kept going for decades longer than anyone had a right to expect. By the time this failure appeared, Voyager was not just old, it was still useful. It was still doing science in a region of space no human being will ever visit. That alone is remarkable. Then, in November 2023, the engineering and science data it sent home became unreadable. Imagine receiving a message from the most distant machine humanity has ever built, only to find that every sentence had dissolved into gibberish. Engineers traced the problem to the Flight Data Subsystem, the onboard computer responsible for collecting engineering and science information and preparing it for transmission back to Earth. In other words, Voyager still had information to send. The problem was the system that organized that information before it went home. At that point, NASA had to begin one of the slowest debugging sessions in history. They sent commands from Earth and waited nearly a day for those commands to arrive. Then they waited nearly another day for Voyager's response to come back. Every test was slow, expensive, and filled with uncertainty. Eventually, the team found the cause. A small portion of memory inside the Flight Data Subsystem had been corrupted. About 3% of it was affected, and NASA concluded that one chip storing part of that memory was likely no longer functioning properly. On a modern device, a failed chip might mean replacement. In deep space, replacement does not exist. No technician can visit Voyager. No cargo mission can deliver new hardware. If something breaks out there, the only real hope is that engineers on Earth can think their way around the damage. That is exactly what happened. NASA could not repair the failed chip, so the team came up with a workaround. They decided to move the affected code away from the damaged area of memory and place it into healthy sections instead. But even that was not simple. There was no single clean block of free memory large enough to hold everything in one place. So the code had to be divided into smaller sections, stored in different parts of memory, and then carefully reconnected so the whole system would still function as one. That is what makes this story so impressive. NASA was not simply fixing an old computer, it was teaching a spacecraft from the 1970s to work around its own internal damage while operating billions of miles away in interstellar space. And because this was Voyager, the team could not test quickly. They had to send a change, wait nearly 2 days, study the result, and then decide on the next step. Every move required patience and precision, because each attempt carried real risk. The first major goal was to restore engineering telemetry. Before Voyager could return fully to science, NASA needed to know that the spacecraft itself was healthy and understandable again. In April 2024, the team sent a critical update. When the response finally came back, Voyager 1 was once again returning usable engineering data for the first time in months. That was the turning point. It meant the spacecraft was making sense again. From there, NASA kept going. Additional fixes were sent, and gradually the science instruments began to recover. First, 2 of Voyager 1's 4 science instruments returned to normal operation. Then the remaining 2 followed. By June 2024, NASA announced that all 4 science instruments were once again returning usable data. The rescue had worked. The most distant machine humanity has ever built had suffered a memory-related failure, and instead of losing it, engineers on Earth found a way to keep it alive and scientifically productive nearly 50 years after launch. That is why this story matters. It is not just about distance, and it is not just about old hardware. It is about the kind of engineering that remains understandable, durable, and flexible enough to be rescued long after its expected lifetime should have ended. Voyager 1 is still out there, still moving through interstellar space and still sending knowledge home from the dark. And maybe that is the most beautiful part of all. It is not surviving because nothing went wrong. It is surviving because when something finally did go wrong, humans were still clever enough to understand it and fight back. If you enjoyed this deep dive, like the video and subscribe for more stories where engineering becomes so extreme that it starts to feel almost philosophical. And here is the question. What impresses you more? That humans built Voyager 1 in 1977? Or that decades later they were still able to save it from across interstellar space?